Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is product rule in differentiation. Let us see what is meant by product rule and how it is used in differentiation. The product rule is used when we want to differentiate a function that may be regarded as a product of one or more simpler functions. If a function is f of x, please consider this function. For example, a function is the product of two functions. For say, we can say h of x is equal to product of f of x and g of x, product of two different functions, where f and g are simpler functions. Then the product rule may be stated as differentiation, derivative of d over dx f of x g of x is equal to f of x times g dash of x plus f dash of x times g of x. In words, we can say this as that to differentiate a product, we add the derivative of the first times the second to the first times the derivative of the second. Does this make sense to you? This formula is very simple. Keep the first function as it is, multiply it with the derivative of the second function. Plus sign in between, multiply the second function as it is with the derivative of the first function. That's it. Let us see how to apply this formula in some examples so you can understand how the product rule works in differentiation. Here is our first example. Here I have taken very simple polynomials. In our further examples, we can take some trigonometric functions also. So please look at this question. Here is a function f of x. It is a product of two other functions, two other simpler functions. In this case, we could proceed by multiplying out the product and then differentiating the result. However, this has a couple of drawbacks in that. It would take quite a lot of work, and also the chance of making a mistake is high. Am I right? If we just apply the product rule, if we just distribute and take the differentiation, there are many chances for mistake. So a much better method is to use the product rule here. So let our functions, these two functions, be g and x. For your convenience, I am going to state this as g of x and h of x. Also, let us find g dash of x and h dash of x, and then we will be just going to plug in these expressions in the formula. That would be very easy. Initially, I have stated what is g of x and h of x. Now I am going to find g dash of x, derivative of this function, and then I am going to find derivative of the second simpler function. Now you have to find the derivative of each and every term within the parenthesis. So the reason why I chose this example is you can see the application of other formulas also here. Okay, let us find the derivative of each and every term within the parenthesis. Here we are going to apply power rule, and here just take the coefficient outside and take the power rule, and rule of the variable and rule of the constant. Okay, so finding the differentiation will give us, so we have got a derivative for g of x. Same way, let us also find the derivative of h of x. H dash of x is what we are going to find now. Same as the previous step, we are going to find the derivative of each and every term. So here we have some negative signs. So please be careful with the negative signs. You should not ignore that. You should include that too in your next step. So derivative of negative 2x cube is going to be negative 6x square. And this is going to be 8x minus 5. And this is going to be 0, because derivative of any constant is just 0, no? Okay. So far we have got g of x, h of x from the question, and we found g dash of x and h dash of x. Now all we are going to do is, I'm just going to write the product rule, and then we are going to plug in the respective expressions. Initially, if you have just started the practice, you can write the formula for each and every problem. So once you get practice in this topic, you need not mention the formula. You can directly plug in these expressions and move towards the answer. So here, let me plug in g of x and h dash of x here, g dash of x and h of x here. So I'll get, this is our next step. So as an exercise, I'm going to give you this. You can try multiplying out this expression for the derivative of f, and then multiply the expression out for f. Differentiate it, and please check that you get the same result. If you do this, you can see that the product rule makes the differentiation much easier. Hope you're clear with this first example. Okay, cool. Let us move on to the second example. In second example, let me take two different functions. One from trigonometry and one is just a normal algebraic expression. Here is the next example. In this case, we don't have any choice. We have to use the product rule only. Even if we multiply out the brackets, we will still end up with the product 2x square cos 3x. So, let our functions, these two, be g and h. We are going to find what is g and h, and we are going to find g dash of x and h dash of x. Let's do the process very similar to the previous one. Let's find the derivative of each of the simpler function. Next, we have to use the product rule. Product rule formula is, just plug in g dash of x, h dash of x, h of x and g of x. And our final answer is going to be, if you just distribute, you'll be getting 4x cos 3x. And for this one, you'll be getting negative 6. So this is going to be negative 6 x square sine 3x. Okay, you can also take the common factor out. You just multiply negative 6 times x square minus 1 sine 3x. That's it for this problem. Hope you're clear with all the steps. Okay, in case if you have any query regarding the product rule, you can let me know. Let me also explain few more examples. Let me take exponential function now. Steps are same thing. You have to identify, or you have to state two functions, g of x and h of x, from the question, and then you have to apply the rules to find the derivative of two simpler functions, and then just plug in the values, the expressions you're getting for the g dash of x, h dash of x in the product rule formula, and simplify the answer. Steps are very easy. Our next example in this video is an exponential function along with the trigonometric function. So let our functions g and h be, g is 5 e raised to negative 3x and h is cos 3x minus 5 sin 2x. Let's now find g dash of x for this one and h dash of x for this expression. G dash of x is 5 e raised to negative 3x times negative 3. Hope you're clear with the step. Now let us identify what is h of x and find h dash of x. So before starting any differentiation problem, kindly have a glance over all the formulas once. Okay, here derivative of cos 3x is going to be negative sin 3x times negative 3. So negative 3 sin 3x. And for this one, negative 5 sin 2x. So its derivative is going to be cos 2x. Already we have a coefficient, and 2x if you differentiate it again, so you'll get 2. So 5 times 2 is 10, negative 10 cos 2x. Hope you're clear till this step. Okay, now let's use the product rule, and we see that the derivative of the function f is going to be, let me plug in these values here in the formula. After plugging in, just distribute. That would be your final answer. Hope you're clear with this example. You'll be getting questions which involves trigonometric function, natural log, algebraic function, any polynomial. So please be clear while identifying which one is g and which one is h, and then apply whatever rule is needed for that problem to find the derivative of g and h, the simpler functions, and then plug in whatever you got in the product rule formula. Concept is very simple. Please look at this example. We have three functions. Here we have a product of three functions. So we have to use the product rule twice. This function is multiplied with this one. So use product rule once. And finally, this answer is going to be multiplied with the third function. That's the reason we are going to use product rule twice here. In general, it does not matter if we express f as f of x. Okay, both are same. So I'm going to, just like grouping, I'm going to group any two functions. For example, yeah, we can group like this. First function, second and third. First and second and third. You can apply the product rule for the innermost function and then apply the result. Take the result and multiply it with the previous one. You can follow any method. You can group in this way, in either of the way. You can find the differentiation of any number of products, any number of product of the functions. Product rule is one of the essential differentiation rule. In any calculus textbook, you can see in the introduction, this rule is just deduction using the definition of the derivative. Each time differentiate a different function in the product and then add the two terms together. The product rule is just a formal rule for differentiating problems where one function is multiplied by the other. Okay. So all you have to do is just memorize the formula. This formula is not that hard to memorize. It will be one thing I can tell you. You can just compare the product rule with the quotient rule so that you can easily memorize those two rules. You should also know the difference between these two rules. You'll be using plus sign in between in product rule and negative sign in between in the quotient rule. So this is all about product rule in differentiation. In case if you have any query or any doubts regarding this topic, kindly let me know. See you in the next video. Have a